Hi, I'm Mike Hutjens, Extension Dairy Specialist at the University of Illinois. This module will look at the Dairy NRC and protein applications. The first major change you will see is a new term called metabolizable protein, or MP. Metabolizable protein really is the true protein digested to amino acids and absorbed from the small intestine. There are two sources of MP, or metabolizable protein: those that come from rumen undegradable protein, and those that come from microbial amino acids that are synthesized in the rumen by the microbes. For some of us who use the old system, it was called absorbable protein in NRC 1989. Not many people use it, but it was a similar term, but now we're calling it metabolizable protein. Finally, for those of us who have some lack of comfort with metabolizable protein, when you use the model and run the rations, it will reconvert it back to a crude protein basis so we can relate to it on a crude protein basis besides metabolizable protein. Three fractions will be found in the feed tables, which we'll discuss a little bit more in detail a bit later. The first fraction is called the A fraction. That fraction is immediately available in the rumen. Very similar to soluble protein, which is not listed in the new NRC, even though some of us like to use that, or you might call it a urea-like product. Milk casein would fall in that category as well as urea. It goes very, very quickly. We need a very rapid source of rumen fermentable carbohydrate so the microbes can grab this so it doesn't spill over into the bloodstream and raise the blood urea nitrogen and milk urea nitrogen values. The second fraction is the B fraction. This fraction is degraded in the rumen over time, and you can adjust that as a user, depending on the type of protein and the processing of that protein. More about that in just a few minutes. And finally is the C fraction, which is that fraction not degraded in the protein. Part of this would be unavailable in the total tract, but most of it would be your rumen undegradable protein in this fraction. Let's look at the rumen undegradable protein portion first. RUP, which is now the new term, is not a constant value. It will change depending on such things as the rate of degradation of the B fraction, which you can change in the model, and how that is impacted by dry matter intake, which means as you have higher dry matter intakes, we also get higher RUP. So you have two variables in the real world that allow this value to change. Processing also becomes a factor, such as heat treatment of roasted soybeans, which also will impact rumen undegradable protein. The bottom line is that soybean meal no longer is 35 or 29 or whatever favorite number you had from the NRC 89. This value will be higher and variable from ration to ration. Let's look at some of the effects of intake. Here is your RUP, rumen undegradable protein values, based at 2% of body weight, which would probably be a cow giving around 30 or 40 pounds of milk, one at 4% of body weight, a high-producing cow, probably giving in excess of 80 pounds of milk. Look at blood meal. When it's at 2% of body weight, about 71% of the crude protein would be RUP. At the higher intakes, it goes up. So you can see that there is no clear pattern here. The number will jump around depending on the type of feed and the intake on these animals. Shows a tremendous dynamics to the program, but it's almost impossible for you and I to estimate without having our model running. The second portion will be the microbial protein. And here are the standard values coming out of the booklet. First, we estimate about 80 grams per pound of discounted TDN would apply. We then consider it as 80% crude protein of the microbial protein, and we assume it to be 80% digestible. Obviously, we made some assumptions here, and the new researchers indicate all microbial protein is not created equal, but this is a good starting point for our model. Now let's go to the feed tables. You will find a very unique table that is dedicated totally to protein. And here's what you'll find for every feed stuff. You will find a value for crude protein content percentage, i.e. the old system. We'll have a new term that's a bit new to you and I, and that's NDICP, standing for neutral detergent insoluble crude protein. This is that protein that is less available in the digestive tract. And another term, ADICP, which is its counterpart, acid detergent insoluble crude protein. And again, values that become important in calculating availability of protein and meeting protein requirements. As we mentioned earlier, you'll have the A, B, and C fractions as expressed as a percent of crude protein. And now you will have the KD value. The KD value of the B fraction simply says what percent of the protein is degraded each hour. Again, a very difficult number for you and I to change because we don't have the data or the research on farm to change that value, but very powerful in research labs. In the table, you'll have two RUP values listed at 2% and 4% of body weight. And finally, how digestible the rumen undegradable protein is. For example, meat and bone meal has a lower digestibility than blood meal, and that becomes important as we look at intestinal absorption. And finally, you will have an amino acid profile on that feed expressed two ways, percent of crude protein and a percent of essential amino acids. This is on every feed in the table. So let's look at an example. Let's go back to our old buddy, alfalfa haylage, immature. You will find that these are based out by forage qualities, and this is what you'd find in the table. 18.3% crude protein, about 4.3% of the protein as NDICP, 1.1% would be acid detergent insoluble crude protein. Now we come down to the various fractions, the A fraction 60%, the B fraction 32%, the C fraction 8%. Obviously, if this haylage gets wetter or drier, these fractions will change around. And as a user, you should make those adjustments as you get comfortable with the model. The rate constant is about 8% per hour of the B fraction. Again, this will change depending on particle size, moisture, and fermentation characteristics of the haylage. The RUP of this haylage is 19% at the 2% intake and goes up to 21% at 4%. Notice that change is smaller compared to some of our protein supplements we looked at just a few minutes earlier. That protein of the rumen undegradable is 65% digested in the small intestine. The lysine content, I just picked two of them. Lysine, 3.28% of the crude protein, or 10% of essential amino acids. Methionine, 1.21% crude protein, 3.7% of essential amino acids. So again, you can see a very descriptive aspect of alfalfa haylage. Now, if you're going to really use this on the farm, we should analyze for most of these constituencies and then put it into our model. This may cost you $50 to $75 per feedstuff to get this analysis done, and some labs are now providing what they call the NRC package, and you'd get some of these values. Some of these, of course, are determined in laboratories such as digestible RUP and would not be able to be analyzed routinely. Finally, let's wrap up on amino acids. One of the frustrations you will see when you get the output off the model is that there are no amino acid requirements listed. We just give you the amount of essential or total amino acid in the diet. The user will then have to determine if he is going to use the Cornell, the Penn State, the Degussa, or some other level to determine what should be the actual amount you want to target in the diet. The flow of digestible essential amino acids are calculated by the model and printed out in one of the output screens. And perhaps one thing we should look for is the ratio of lysine to methionine. And this is one thing you can compare. And ideally, it should be somewhere around 3 parts lysine to 1 part methionine in the feeding program. So let's summarize some of the key take-home points on protein. First of all, once you compare the two modules, or the two different programs, the crude protein content is going to be lower in the new NRC, from 1/2 to almost 1.5 points. So if you're normally feeding a 18% crude protein in the old NRC, the new one is going to be slightly lower. Number 2, you're going to have to use the NRC 2001 model to calculate the actual protein and amino acid values and determine what the actual RUP values are. As in some of the other modules, dry matter intake is critical because it affects your rates of passages and some of the other discount values that we talked about in both energy and in protein. And finally, if you're really going to make the model work for you, you are probably going to have to test your feeds for the A, B, and C fractions because they are needed to refine the model and to get accurate information. Well, that completes this module on protein. Thanks and have a good day.